Hello, hello. Hello, hello. All right. Hello, good evening, friends. Hello, friends. Today I am here to solving the problem based on multi-degree of freedom system of the three-story building. This problem was based on the structural dynamics and the civil engineering. Here we have to be find here the questions. Here the questions. So what is the questions we have to study? Determine the eigenvalue and the eigenvector for the shear building is shown in the figure. Is shown in the figure where this is the figure one. This is one the figure and model shape. Draw the model shape and write the model matrix and calculate the generalized mass and generalized stiffness and also demonstrate the orthogonality properties. Here we have the three-story buildings. Here we have to be analyze the three-story building where the top story mass and stiffness. For stiffness are given on the each and every story. There are three story and the three story are given. Here the solution is done in Excel format, which are useful in the future life. This problem was done on the theoretically. We have on the in the school level, college level, in the classes for the examinations. But we have today I am going to this problem. Today I am here going to solve this problem on the basis of Excel format. How you can form the Excel format and the model matrix. Most of the important things is here the model shape. What the model shape? What the behavior of your building to after the horizontal force or any earthquake load has been applied. Here we are going to solve this problem. Now we start from the stiffness and the mass matrix of the frame of this frame. Here the mass matrix of the given 3 degree of freedom 3 degree system of the mass. How we calculate the mass? Here we are going to calculate the mass matrix, that is a matrix M matrix is equal to what the matrix is always, we have to understand that what the matrix is it, you know. I think it's not working. Okay, what is mass? That is mass means there is mass matrix mass matrix of this building M1 0 0. The diagonal element will be the mass, otherwise all the elements are 0. Okay, mass matrix like this. Our mass matrix like this. Here our mass matrix. What here we have to go draw the line of this shape. We are drawing here the mass matrix like this. Okay. No, I'm not going to draw the box. I'm trying to draw what the hell is going. Okay. Draw the word. Line is style like this. Here and here we have to draw. Okay, the mass matrix like this. Our mass matrix like this, and this is equal to what is the M1 here. Mass matrix is like that, m1 is equal to m1 75, and m2 is there is going to is equal to m2 diagonal elements m3. Okay, all others are 0. This is our uh, matrix, mass matrix. Yes, uh, mass matrix of line style is this. Okay, this is our mass matrix, and now we have to this unit you have to also notify that the unit is kilo newton per meter square. That is kilonewton second square per meter. This is the mass matrix. And the stiffness matrix, what was the stiffness matrix? Stiffness matrix, that is K is equal to, what should have to be do for the stiffness matrix? There, stiffness matrix, that means the stiffness matrix is equal to K11, like we have to write K11, okay, K11, K12, and K13, K21, K22, K23, and K31, K32, K33. This is our matrix. The matrix. What is equal to this? And yes, skip is equal to into yes. This is our stiffness matrix where the K11, K112 like this. Similar the M11, M22. They the matrix order. What does it mean? K11 means when unit, when K1, K1, K2, K3, K1, K in this column K1, 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 2, 3, K1, 2, 3 is show the position, that is K1 position at this position, K2, K3 positions, and K11 means that what K11 means that the load or the force, any the force acting on the one position. The K11 means that at one position, K11 means where at one positions, at one position, at position 1, what was the effect of 1? If any load happen, if there is any load happen, whether insert, okay, this is our controls where I am going to show you. This is our matrix, this is our building structure, and then where say line, if there is one unit force apply here, if unit force apply there, what was the effect of other? Okay, there, like this is called 1. K11 means at one position, K11 means at one position, effect of 1. If there is the del, there is del, del means that is the unit 1, unit force, that is 1. If you the 1, we have to know that f is equal to K1 times del, del, we have to del, where is del? Okay, wait, escape symbol, we have to insert equation symbol. Oh, there is, take our time to finding del. Okay, okay, leave them. You have to know that there is del. F is equal to k into, we have to notice that d, k into del, that is if we have, let the k11 means k11 effect, k11 effect at the position 1, k1 effect, that is force k1 equal k11 at the one position, k1 times d, that is means 1, that's why the k11 is equal to k1. Similarly, k21 at one positions there is unit force, and what were the effect at position 2? That is uh, that is 1, that means the kf into k into d, del f k into del, that is del is 1, and k, what are the effect is k is -1, that is minus k1, that is k, that is -1, that means k 21 k21 is equal to k1 means minus k1 into 1, that is minus k1, so there we have to with minus k1 minus k1 is equal to k1, that is minus k1 is not showing. Okay, insert general number friction general is equal to minus k1. Now if we put the number, then minus k1, why is not showing, bro? You have to understand that there is negative k1, minus k1. Not number, currency, account, short, percentage, time, tax. Minus k1 minus k1 minus k1. And what was the effect at k3 position? At position 3, that means there k31 means k1, it the effect of this, there is no any effect, so there is 0, so there is general 0. And again when this unit force act at the position 2, what were the effect of their effect, मतलब k2 at the position 2, k2 to position 2, if the position 2 have the unit load, if the position 2 have the unit load 1, and what was the effect what was the effect of air? Now that means k1 means that is -1 minus k2 minus, wait, I am here like this, and that means dx better to write takes right. That is here is K2, K1, 1, K2, there is K1, K2 and K3. So K1 minus K1, here is the effect of minus K1. And again, if we effect the position 2, the position 2, effect of position 2, that is K1, K1 into 1, and this is K2, that is K2 into 2. That means K1 plus K2, and again there is the effect of K, that is K2, and it is the coming backward, that means the effect of this into this, that is minus K2. Here K2, that means the one effect of K3 2 means the position 3. What was the effect of K2 at the position 2? Position 2, that means the minus K2. And again this call the condition control. These effects are act here, then what happens if the position 3, if position 3, that means what was the effect of K1, that is K1 at position 1, K1 3, that means at the position K1 3 means at the position 1, what was the effect of K3, that is 0. And again, what was the effect of K2 at the position 2, what was the effect of K3, that is minus K2, and again K3 means K2 plus K3, K2 plus K2 plus K3. Yeah, and there how we check, there is check if their sum, all the sum, that is the summation of horizontal force is equal to 0, like that the summation of this at the position 1 K1, this, if you sum this and that means that is 0, that is K1 minus K2 is equal to 0. And again similarly sum of this sum is 0, K1 cancel, K1 cancel, and this is also sum are 0, but there is not sum, there is come K3, because there is in the base the some force are restrained. If the reaction you have to do if any supporter there may be the reaction, so the K3 is left, so there is no 0. If they continue, if this building are continuously downward, if there is no support, then their sum will be 0 at these positions. Okay, you have to understand it. And again go through that K1, and that is K1 is equal to K1, and it here minus K1, and here is 0, here is minus K2 is equal to minus K2 is equal to K1 plus K2, that is K1 plus K2, and again minus K2 is equal to minus K2, that is not K2, okay, minus K2, again 0, and my is equal to minus K2, and the K2 plus K3 is equal to K2 plus K3. It is our stiffness matrix, that is 4375087 here minus K1, yes, effect up to K1. तेरह 43 minus 87 175 000 ओके and 87 500 13 1250 and there is minus K1. Here is minus K1. What we have done? I think put K2. So that was K minus K1 here. That is this kind. Is K1 plus K2. Okay. Alright. This is our stiffness matrix. What the unit is? Kilonewton per meter. We have find the stiffness matrix here. Line style. Okay. This is our stiffness matrix. Okay, the first work has been finished. That is the mass matrix and the stiffness matrix of the 3 degree we have calculated. Now, obtain the characteristic equations of. Now we have to be obtain the characteristic equations of the associated Eigen value problem and solve it for finding circular frequency omega, that is omega, and corresponding natural period, that is t. And we have the characteristic equation, that is what are the characteristic equation? We have the characteristic equation is see our characteristic equation is this Q1, that is Q1 matrix, that is determinant, characteristic equation determinant of this is equal to 0. It is our characteristic equation. We have to solve these equations and find the value of omega square. What did we find the omega? That is superscript. Okay, there we go. It is superscript. Okay, that is fine. Now what we have to do for this? We have to be computed here omega. We have to compute omega is equal to something. We have to be find and omega square is equal to omega square is equal to this into this, that is omega square. Okay, and we have to find the equation value of this to calculate this. Okay, we have to find like this. We have the K matrix. Here is our the K matrix and omega, that is this. Assume here I am assuming W is equal to something that may be value. Right now again we have to be find. First of all we have to let this and omega square is equal to this and M matrix I have. Now we have to be find, suppose let F matrix. Okay, F matrix is equal to matrix is equal to, what is our f matrix is equal to k times that is equal to k1 k times minus k matrix minus wn square मतलब w square into 4. But this value and this here k and m are changed, but the omega is not going to be changed. So here we have to put a dollar sign, then press enter. That is 433, and similarly calculate this and calculate this one using this. Why it is not happen? Wait. There may be, I think, fault. Control Z. Omega square can't be shift anyway. There is also put a dollar sign, dollar I, dollar. That means the omega value can't be changed. Enter M1. Okay. This and this we have calculated. This is our AF, that is model. We have calculated the F force, F matrix, that is omega is equal to given this minus this into this, that is what we calculated k minus omega square value, that is omega square into m. Okay, all right, this was the solve. Okay, now we have find the determinant of determinant of f matrix. F matrix is equal to determinant of F matrix is equal to matrix matrix wait. What we have to do? We have to calculate the determinant M determinant. We have to put is equal to M determinant and select the array. And we have to select the array, that is this one. Enter. We have calculated the determinant of that matrix. We have calculated the determinant of this matrix. This process was only exit in Excel, otherwise we have to solve completely. If we done theoretically in our copy, then you could this equation. You have k known and m known, and here is omega square known. You have to let the omega square is equal to something x or b, and then you have to solve and find the determinant. Then determinant is equal to 0. There is came the equations, and then you can find by calculating, solving this polynomial equation, I think came, and then you have to solve that polynomial equations, and you got the three value, omega 1, omega 2, and omega 3. But we have in the Excel, we have to calculate these terms here, and determinant of these terms here. Yep. And now what we have to do to find the omega, you have to go the file, options, click add inst, and go, and you have to all on the solve add information. Okay, if you tick this solve add info, then here you have to tick this one, and here insert, you have to go insert. No, you have to go the data, and there is the option of solve. So you click the solve option. if we select this, here set the objective value of f, determinant value, and here is the value of 0, that is that function is equal to 0. We have the function that is 0, so put the 0, and the variable you have changed, this variable we are going to change, and click OK and solve. That means then you have got omega 1, you have got omega 1 is equal to, we have got the omega 1, that is equal to, this is your omega 1. Similarly we have to find the omega 2, omega 3. How you have to buy? There is the omega 3 value. Why? Because there is a 3-story building, and so we have to be 3 unknown, omega 1, omega 2, omega 3. So where I am going to find that omega 1. Okay, fine. How you have compute the omega 2? Omega 2 compute, you have to click this value and press solve. This value is as it is, this value is as it is, and this value is also as it is. But here you have to be add something, the reference value, that is your this value, here you this value greater or equal to sign, greater or equal to, greater than 7.8, there is 7.8, that is we have to put 8, greater than 8 value. Okay, so okay, here we have it and solve, that is another value is 18. Oh no, control Z, we can't be solve. Okay, there we have to go back, because okay, this is the previous value one, this one solve. Okay, no, control Z can't be okay. No, okay, all right. Here we have minus this value, that is this is equal to this omega value, and there you have to solve this one, that is f is equal to 0, f30 you have to be change this and solve. Okay, you have to not put there, you have to copy and paste, so there is no value change, and again solve, select this equation, solve, and you have to put the objective value, that is f determinant, there is the value 0, and you have the value to change the variables. Still you have to change this variable, you have to be add your value this and greater or equal to 8. Okay, and solve. The another value we have got 18.64, control C, control B. Then we have got the another value also, omega 1, omega 2, omega 2 we got it, omega square, omega 18.48, that is correct. And again we have the first, for the third value, add the cell this is greater or equal to, greater than 18, that is 18, that means we have to put the 21. Okay, and solve, that the another value is 26.87, control C, control V. We have got the 3 value of omega, and we have to compute. Now we have also there find the t, that is we have calculated this and their equation solving, and we have to also calculate the time period, that is t1, t2, t3 is equal to t1 is equal to, what the t1 is equal to 2 pi by omega 1 is equal to 2 into pi value means 3.14. What is the value of omega? What is the value of pi? Pi means 3.1415. 3.14159 into omega is equal to this 50 2 pi by omega we have to put, okay? That is 2 pi by omega 0.78 second, and similarly this also calculate 0.34, and the time may be time must be decreasing order. Second. We have computed this. We have the computed the omega 1, omega 2, omega 3. We have to find the characteristic equations. Now what we have to be find? Now we have to be find the modal matrix, that is phi. We have to compute phi. What we have to be do? Here for we are going to for FIRST first MODES modes. We have to calculate the modes. MODES modes when omega 1 omega 1 square is equal to omega 1 square is equal to this into this omega square. What we have to do? We have the matrix. From where this you have to use this equation, k minus omega 1 omega square m phi n. Okay, using this equation we have insert that is Control C. Using this equation, told you we are using this equation and find the phi for the mod 1 matrix, that is that maybe is equal to, that is k matrix is equal to k minus omega square. We have to put the dollar sign here. Q1 this into Q1 into M, that is the is put the dollar sign into M1 is equal to this, and similarly we have calculated all this value, and similarly this value calculated this, that is K01 K times omega square K times K minus omega square into M. Have calculated this value. We have calculated Q1 into here we are 32.7. Okay, this 43 0 0 and 37. Okay, all right. This value and this value is multiply with 511, 522 and 533. insert x equal, we have calculated 511 522, that is 5 matrix, that is Q1. 5 matrix is equal to 0. We have these equations, we have got this equation. We have got this equation is equal to 0. Here we let us assume let us assume let us assume 511 is equal to unit is equal to 511 is equal to 1. We have assumed, okay. And now this matrix is similar, okay. Here we have put a borderline that make the attractive. This value we have copy, again multiply with this value are similar, but this value is equal to this, so this value is equal to 1 again. Now we have calculated control C, group P 5. We have to calculate the 511 522. Okay, we have to look anyone is responsive. No one. Okay, all right. This is equal to, we have used, what we have to do, use this matrix multiply with, if you multiply this matrix with this is equal to, keep the equation in this, we multiply this matrix into this matrix is equal to 0. That is how we calculate this into this plus this into this plus this into this is equal to 0. That is we have to compute here, that is 30. That means this is equal to 0. Okay, all right. This value is equal to this value, this 511. That means 511 is equal to 1. 511 is equal to 1 and 522 we have to do for 422, multiply this matrix with this. What we have to do is equal to this into this plus this into this into is equal to this into this plus this into this, but we have not put this. This will going to the other side, there will be change plus this into this. this value, but there is coming -1. Negative. We are solving this equation is equal to this into this into this plus this into this by this. Why this happened? Minus into, well, that is okay, I think. Why this happened? This into this plus oh, there is the value, because this value is not working. Okay, this value must be 0, so we should not have to be put. That value is 0, that is this. That's why again we have to put is equal to, we have multiply, we have to this equation into this equation. Here q11 is 0, q2 is this, and q3 is unknown, so is equal to minus bracket I think this value is negative here. No, minus is equal to this into this this into this plus this into phi 2. That means this value plus this into phi 2, that is phi 2, that is phi 2, this bracket close by phi 3, this value, and that is 0.424. We have calculated this one. This is okay. That is our, that's why we have solving these equations. We have get phi 11, phi 21 and phi 31. Again we have done for the, we have doing this for the first matrix, and again we have done for omega 2 for the second mode. Second mode. Now we have for the second mode, omega 2 is equal to 0, that is equal to omega 2 331. These values are similar. Control C, Control V, these all values are same. Here all the values are same, but there will change of this value only. We have put the dollar sign, dollar sign, dollar sign. Why is not coming, bro? all right, is equal to k matrix minus omega square dollar sign omega square into m is equal to this value. Okay, this value came. Control C, Control V, this value are copy there, and okay. After that, the 511 is this value is then 5 date because they are going to shift the 5 to position. 5 2 2 1. Okay, last value position only change. Yeah? That is 2. That is 2. This 2. Okay. 512, 522 and 53. We have got the 522, 533 value. This is our value, required value. 522, 512, 522 and 523 as the required value. 550. Okay, all right. And we have shift for the model third matrix. We have use Control C, Control B. Okay, all right. Here we have to put 3, and we have to put 3, 4, skip, 3, in this case we have to put 1 2 is equal to 0, 1 2 0, and in this matrix 1 3 is equal to 1. Okay. Omega 3 is equal to omega 3 is equal to omega 3 square is equal to this into this into omega 3 square alkane. Now small is equal to k minus omega square into m, but omega square can't be changed, so use the dollar sign. Okay, okay, and okay. And this value Control C, control B. There we have to put the beta is equal to this is equal to this. So we have put like this and sloped. There will be most better. Yeah? Is equal to this is equal to this. I think it will better. One 0.1, 0.355, 0.558. Okay, all right. And there is another matrix there. We have put this and we have got 5 to 1 is equal to 1, 889 and 2.124. That is correct. Here we have got MODAL model, MATRIX matrix, modal matrix, that is phi is equal to model matrix phi is equal to control C is equal to this is equal to this. This is our model matrix. Here we have got the model matrix. It is our required model matrix. If anyone has any problems in this solution, then message me. I will reply. We have find the model matrix, that is 0, 1, 4, 5 and 4 to 6 and this one and this one. Now we have to withdraw the model shape. What we are going to have to solve, that is we have to be find model shape. What we have done for the model shape, we have go in insert layout formula. We have go to the insert, that is bar graph more. Okay here more chat, select the chat. Okay, we are selecting this one and go more, and here we have to plot line, no line, not xy coordinate. Okay, xy coordinate of this type, this one. Okay, wait, I think that will be the default program. Wait, what we have done for this, template select data 0. We have to put opposite 0, this one, this one. We have to be plot in the different order. So okay, here we have door of 0 4 1. Okay, we have put 0 0 for the graph. We have to do this work because this control V is equal to this 4 to 7 here is equal to this is equal to this. Okay, we have got this. We have to select this and we have to go bar chart and more xy coordinate split this type of we have to select xy coordinate this and this. Okay, there writing mistake. Okay, change type restore math system, change type, change template, select data. Remove, add title name. What we have to be add the title name? Add the title name mod 1. mod 1. Edit mod 1 x-axis. We have to select this one. At y-axis we have to plot 1 comma 2 comma 3 comma 0 comma 1 comma 2 comma 3 comma 4. Okay, enter. That is it is a 0 0. Here the 1, here the 1, that is 0.4. or at the here we have at the 0 0, at the 0 0, at 1, at 1, to 1 we have got 0.4. okay, at 2 we have got 0.7. okay, at the 3 1. okay. Again, for the second model matrix, insert this square is created, this with this matrix. I think we did it. What we have to add for the point? So title bar guideline data level here you have to put this change template type, put this one. Okay. Is it looking uniform? Yeah. Now go for the second model. This skated type, this one. Okay. Press here, select change, type change, template, select data, remove, add, x-axis, ODE mode 2, x-axis value is like this, and this value 0, 1, 2, 3. Okay, this. This is our model matrix to delete this. If we have to we draw a line, then solid line, border, transparent line, beginning arrow, fill, set. All right. This is our second one. Third one, better to control C. This can't be copy. Copy paste. mod 3 x-axis value name 0, 1, 2, 3. This is our third mode. Here we have a conclude for the mode 1, mode 2 and mode 3. This is our model shape. How our building deformed.